Hello everybody and welcome to today's video. We're going to be talking about using the input system with Unity's data-oriented technology stack and their entity component system. Now of course many videos on my channel focus around Unity Dots, and so now that Unity Dots is fully supported and production ready as of the 2022 LTS launch, I think it's really important that we talk about some of the topics about how to start integrating different features of the Unity game engine or just kind of general important things to game development into our Unity Dots projects. Now we already have seen a number of production ready games available. Here's just a couple examples of them. By the way, if you're not familiar with Unity Dots, here's kind of some of the features. It's kind of centered around the entity component system, and there's also the job system, the burst compiler. Another important factor is netcode for entities. I did a whole video kind of going into detail about what Dots is and should you use it. I'll have a link to that video down in the description for you if you need it. But really the main point that I want to get across is Dots is kind of a different way of thinking about things because it uses data-oriented design rather than object-oriented programming. So we kind of do have to approach integrating things like the input system and UI in different ways. So I do want to make a bunch of videos, kind of talking about these topics. So if you do have any suggestions for things that you'd like to see, feel free to leave those down in the comment section below. But anyways, getting back to today's video, what we're going to be talking about is the input system. Now this is kind of the newer input system that's actually been out for a couple years now, but it really is just a really flexible and good system that allows us to basically configure all different types of control schemes for different types of input, whether our games that we're targeting are for PC, mobile, console, anything like that. We can easily set up different control schemes and input actions to support all of these. So it's just a really great and flexible system, and it's something that I would highly recommend using in your Unity project by default. Now, anyways, today's video is not going to be an in-depth look into the input system. I'm going to be showing you, everything that you need to set up in order to get your project working with Dots, even if you've never touched the input system before. So it may be an introduction for some people, but I would highly encourage you to go do some more research into the input system because there are a lot of different things that you can do with it. So I'm going to go ahead and leave some links down in the description for some of my favorite resources for learning about the new input system. So anyways, talking a little bit about how we actually use this with Dots, there's kind of a couple steps that we need to go through to basically handle our input actions. Now, the first thing that we need to do is actually create and configure our input asset. So this is something that we need to do with the new input system. We basically create this asset, and this is where we map kind of our key bindings. Basically we can say this is where we press the WASD keys to move the player around, or we can press the space bar to make the player jump. This is kind of where we just define all of the, base input actions that our player is going to be dealing with. Next is when we get into some of the Dot specific stuff. We're actually going to create a system base system, which is actually going to read our input. Now we're going to put this system base in sort of the initialization system group, which is kind of the first step of the ECS player loop. And that way it's going to happen before all of our gameplay systems. The reason we do this because also in this system, we're going to be writing these results to a data component. Typically, it's going to be a singleton data component, but maybe there are some circumstances where you would want to write data to a specific entity over another one. But in this case, we're just going to be using a singleton data component. Now, once we've written to that, again, we're writing to that in the initialization group. We can have any systems kind of in our main simulation system group basically read that input data. So again, we're only really reading data from the input system just that one time, and then we're setting up a component that can be referenced from any other one of our systems. So this is really nice. Again, we're just kind of getting input from our player in just one spot, and then many other systems can reference that data as needed that can do different things. So as an example, let's say when the player presses the space bar, it's going to cause the player to jump. Well, what we can do is actually have multiple systems to essentially reference that component that has been written to know when the player needs to jump, and we can have one system that actually begins performing the jump, and we can have another system that maybe can play some sound effects or maybe decrease some stamina. So these things can kind of all be separate, and it kind of lends into that data-oriented design pattern. And then anyways, the final thing that we may or may not need to do is reset our input data. And so there are some circumstances that we may need to do this and other circumstances that we won't necessarily need to do this. And that is because there's actually going to be two ways that I'm going to be showing you how to read input today. So the first way is to just continuously read input. So this is good for, if we have any player joystick movement. So if the player is kind of just moving the joystick around to move their player around, we can continuously read that because it's also valid for when the player is not touching the joystick, that we don't want the player to continue moving. Same thing for if we had like a trigger on a controller that we wanted to use to control, how quickly a car is accelerating. We can continuously read that value and see, what percentage and kind of where that trigger is at in its travel. So we know, how much acceleration force to apply to the car in our game. The other option is kind of more an event-based approach, and this is best for when we're like pressing buttons. We're not going to be like continuously reading, what the value of that button is. Basically, we're going to have an event-based approach where we're going to kind of hook into some of the existing Unity input systems events so that we know, when a key is pressed or released, that we can kind of write to the proper data components. So again, this would be good for, any type of inputs where the player just needs to, press a button for something to happen. Maybe they're interacting with something in the world or so on. And this would be one of those cases where, maybe we're writing to a data component and at the end of the frame, we're actually going to need to reset it. So I'm going to be showing you how to do all that here right now. Okay, so here we are over in Unity. Again, the first thing we need to do is create our input actions asset. Basically, the way that we can do that is just right click in our project view here, go for to create, and then all the way down to input actions. Now we can go ahead and say, call this the demo movement actions. And we can just go ahead and double click this to open up the window here. So again, we're just doing a very simple setup here. So first we're going to go ahead and create an action map, and we can just go ahead and call this the demo map. Now we can go over to this new action here, and this is where we're actually going to set up our player movement. So we'll go ahead and set up our player movement here first. So we can just call this player movement, just like that. Now, before we add any key bindings to this action, we're going to go ahead and change the action type from button to value, and our control type is going to be a vector2. So again, because we're going to be moving our player using the WASD or the arrow keys, we're going to go ahead and set this up as a vector2, so it has kind of the two different axes that we are looking for. Now if we just go over to the plus for the add binding here, we can go ahead and say add the up, down, left, right composite, and then here we can call this, say, the WASD movement. Now we're going to go here and basically set up all the different keys. So for example, the up key, we're going to go ahead and set this to the W key. So the way we do that is basically select this, and then over here where we say path, this is where we can actually put the key. Now, unfortunately, it's a little bit hidden, but there actually is a listen button that's kind of behind this here. So if you click on this, you see it says listening for access. So if I just press the W key, we can go ahead and now select the W key. And then so same thing with, say, the down, we can go here and we'll say listen, and then we'll set this to the S key. Left, go here, listen, this is going to be the A key. And then finally right, listen, this is going to be the D key. Now, of course, because we want to give our player more options than using, say, just the W, A, S, and D keys, we can go ahead and back up to the player movement. We can go ahead and add another up, down, left, right composite, and this one will be the arrow keys. And then so here we can kind of do the same thing where we can just basically map the different keys by clicking the arrow keys and listening for that. So I'll go ahead and do that now. And one other thing that I'd like to point out about these two input actions for WASD and arrow keys, you'll see that our composite type is a 2D vector. Again, we want the XY axis for if the player is, pressing up, down, or left or right. And then our mode is also going to be set to digital normalized. I typically use this, and that's because, if we're, say, pressing the W and A keys to move up and to the left, it's basically just normalizing that vector to be a length of 1, so that when we say multiply by our move speed, we're not moving extra fast when we're moving in a diagonal direction. However, it may be different for your game, so maybe you want an analog or digital mode, so just go ahead and keep that in mind. Okay, great. So once we have our player movement set up, we're going to go ahead and add in one more action, and this is going to be our jump action. So we can just call this, say, player jump. And then here, we're just going to go ahead and set up one binding. We'll just use this as the space key. So we'll just go ahead and add the space key there. Now, very important that once we're done, we can just go ahead and click Save Asset. and that's actually just going to go ahead and save the asset. Now we can close that. Next important thing that we need to do is we need to generate a C# class so we can access these input actions from our system base. So go ahead and check mark that box and then click apply. And you'll see it's going to go ahead and take a moment to actually go ahead and generate this new class file here. And so you can see this is actually the class file that it's automatically generated. You know, it has kind of all the different maps and everything that we just inputted. So that's all kind of, available to us to access through code now. Okay, so now we're going to go over to our IDE and we're going to configure our system where we're actually getting input. So again, I call this the get player input system. Now, like I mentioned in the theory section of this video, we want to go ahead and actually do an update in group type of initialization system group. And I like to put this actually at the end of the initialization group, just so it's kind of running after Unity's default initialization logic. That's just kind of a personal preference for me. Again, we're doing this in the initialization system group because by default, most of our gameplay systems are going to be in the simulation system group. So that kind of guarantees that, any system that's running in the simulation group that needs to, say, reference some of the input data components that we're writing to, those are always going to have the current up-to-date information for that frame because it's kind of referencing that data after it has been written to for that frame. So it's always going to be kind of the most accurate for us. So you see that I kind of have just like a couple basic things set up in the system already. But one thing that I do actually need to add is our demo movement actions. So we can just go ahead and add this as a field of this system base here. Now in the onCreate, we actually need to go ahead and initialize these input actions. So the way we can do that is just by taking our demo movement actions variable, set this equal to a new demo movement actions. Now after that, in the onStart running, we're actually going to go ahead and do the demo movement actions.enable, which is actually going to enable the input actions, meaning that we can actually use them. And then similarly, I like to just go in the onStop running and just do a demo movement actions.disable, just so we know that, if the system stops running, those input actions will be disabled. So now that our movement actions are properly enabled, let's go ahead and do the first approach where we're just can be constantly reading the value from the input actions. So again, we're going to be using this for our player movement. So here we can just set up a new variable called cur move input. We're going to go ahead and set this equal to our demo movement actions, and then now we need to go ahead and actually access the input map, which I just called the demo map, and then we can go ahead to our actual player movement action. From here we can go ahead and do a read value. Again, the type that we basically told the input action that it was a vector2. And so again, it's just going to be continuously reading whatever that current value from our move input is. So now once we actually have our current move input, again, this is just kind of reading it and storing it into a local variable here. We actually need to go ahead and write this. Again, we're going to be writing this to a singleton component. And so we can easily do this using the system API.set singleton. And here we can just say a new player move input. And again, this is a custom type. I can show you what this looks like in just a second. So cur move input, just like that. So this player move input, we can go ahead and take a look at this here. You can see that this is just a public float2 value. Again, this float2 type is part of that new unity.mathematics library that is the fully burst compatible type. It's very similar to what a vector2 is. And in fact, there is an implicit conversion from vector2 to float2. So that's how we can just take our current input as a vector2 and add it to this movement input data as a float2. Now for this demo project, I have this player move input. This is actually living on the player entity, but there's no reason that we couldn't have, say, a dedicated input entity. There's a lot of cases where I do end up having a dedicated input entity that has, all the components for any input, just kind of on its own dedicated thing here. But again, this on update will just continuously keep this player movement value updated. We don't have to do any resetting or anything like that, because if the player is not pressing any keys, then the player move input is just going to be set to values of 0, 0. And then when we actually go ahead and move our player and we reference our move input, the 0, 0 values are going to be meaning that it doesn't move in any direction. So I can kind of show you what this looks like. So I have this player move system here, and this is again just running in the regular simulation system group, which is just scheduling this simple player move job. Looking in here, you'll see that basically I'm going to be modifying the local transform component of our player, and it's going to be reading in from that player move input as well as our player move speed, so we can have a multiplier for how quickly the player can move. And you'll see that basically what I'm doing here is just doing a transform position.xz, just because we're going to be moving our player just in the x and z axis. And then I just do a plus equals, so we're basically, adding to its existing position. Our player move input dot value multiplied by the move speed value multiplied by delta time. So again, this player move input, this is going to be the XY position of whatever the player is pressing. The move speed value is kind of a multiplier, so we can make the player move faster than just kind of a default here. And then finally, we'll multiply by delta time to normalize out for frame rate. And then after this is basically just saying, if the player is still pressing any keys, we're actually going to rotate the player in that proper facing direction. So if we say come over to Unity, now we can go ahead and use the WASD keys to say move our player around. And I can also use the arrow keys to move the player around as well, because we've created both those bindings in our input map. So now the next thing to do is to get it so when we actually press the space bar, our player shoots out a projectile. Okay, so now to show you how to actually fire a projectile, again, this is going to be kind of the event-based approach for gathering input. You'll see that I basically already have this private void for the on player shoot, and this is basically that event that we're going to call whenever the space bar is pressed. You'll see that basically all that's happening in here is we're just making sure that the player entity still exists. If it does, we're going to go ahead and enable this fire projectile tag component, and then we have a system later on that looks for any entities with that fire projectile tag enabled, and when it is, it's just going to go ahead and enable that projectile. Again, all we're doing is just setting it to true here, and then we're going to have a system later on to kind of reset this value to false. You'll see that the onPlayer shoot does take in the input actions.callback context obj, and that is something required for listening into these events. So the way that we're actually going to listen to these events is, say, in the onStartRunning, we're going to go ahead and do demo movement actions.demo map player jump, and there are a couple of events that we can listen to, but I'm just going to go ahead and listen to the performed event. So we can just say plus equals on player shoot, just like that, and then we can just go ahead and copy this line, and then we'll go ahead and move this into the on stop running, and we'll just go ahead and do a minus equals just so that event gets cleaned up if this system gets disabled. And so that's basically all that we need to do, because again, this event's basically just going to get fired, which is going to go ahead and call this method here, which is basically just, again, enabling that fire projectile tag here. And so here's an example of, say, this fire projectile system here. You'll see that we're looking for anything that has this fire projectile tag, and I'm not looking for any disabled components. So again, this query is really only going to execute when we have this fire projectile tag enabled. And you can see that I have just a local entity command buffer where we're just basically instantiating a projectile prefab and setting it to the proper transform of the player and all that. And then finally, I do just want to point out this reset input system. Basically what this is doing, this is actually updating in the simulation system group, but I have it order last equals true. So it's basically going to be one of the last systems to run. And this is actually going to run after the end simulation entity command buffer system. Basically what I'm doing here is I just kind of have a local entity command buffer, and we're just going to go ahead and reset the tag on the fire projectile tag. In this case, basically just the way I have this set up is, as soon as this tag gets enabled in that same frame, it's going to be disabled. So it just kind of resets that value. So we'll come back over to Unity. Again, we can still move our player around with both the WSD and arrow keys. And now when we press the space bar, we can actually fire a projectile into whichever direction the player is facing. So that is basically really exciting stuff. Again, that's kind of how we can utilize the new input system with Unity's data-oriented technology stack and their entity component system. I really do hope you found this video helpful today. Again, do let me know if there are any other videos that you'd like to see me do related to, adding different features into our dots and ECS projects, because a lot of times it does take a little bit of a different way about thinking of things. So, hopefully you got a lot out of this video and it made sense. If you do still have any questions, feel free to leave those down in the comments section below, or join us over on Discord over at tmg.dev/discord. Anyways, I hope you all have a fantastic rest of your day, and I'll see you in the next one.